we're actually wrapping up Git. We've already wrapped up Git. So before we move to the next topic, do you have any question or any concern that you want us to trash out before we really move on? Maybe anyone has any question or what you think we are missing, or what we should know, or what you would like to know about Git before we move on.
Good evening, Mr. Adeyemi. Is that your baby?
Yes, yes.
Oh.
That's my baby. Thanks.
Nice.
Yeah, we can see how you're feeding your baby. With the singles, we are learning.
Now my big bro be that too. Now in hand we grow for like this, so in grow for in hand, they carry us like this up and down.
I was just shouting out.
All right. So let's do it. Today we are going to be talking about Docker. So what is Docker? Now you're talking about Docker. Okay. Docker is more like virtualization. Okay. I don't know, maybe you've heard about virtual machines. A lot of us were asking me questions back then when we wanted to start Linux. Can I install VM? Which VM should I use? You know, a lot of things. A lot of questions were actually raised about VMs. What is VM? VM are virtualizations, right? Like you're having a machine. You know, you're having a machine inside the machine. So it's like you're virtualizing. Yet this is my Windows laptop anyway. Inside this Windows laptop, I can have another OS, you know, or another machine running inside this Windows machine, and probably have it as Linux. Now, don't try to don't mix it up. There's a difference between virtualizing and dual booting. You know, when you are dual booting, you can, by the time you put on your system, it will ask you, okay, do you want to switch to Windows or you want to switch to Linux? No, that's not virtualization, that's dual booting. So virtualization is inside this OS. I'm going to create another machine, you know, that might even still be running the same Windows inside Windows. I can do that. Okay. But now the question is, why are you virtualizing anything? You ask yourself, okay, why do I want to virtualize? Fine, I'm running Windows and I need to do some things, can only work on Linux. What can I do? At the same time, I still want to be using my Windows. Probably I want to be multitasking, you know, working on Windows and still be doing some things on my Linux, you know. So you don't want to do a put in such scenario, you can just virtualize, you know, and have a Linux and a Windows. Now, why are you using Linux? Inside Linux, probably there are some libraries or there are some applications. Let me just say that there are some applications you want to make use of that is inside Linux but are not readily available inside Windows. Okay, or there are some things that you can only get done on Linux, but you cannot get it done on Windows. You know, so those are some of the reasons why you want to virtualize. Or probably you are trying to work on a software, or you bought an application. You can even buy an application, just like you're using your Android now. There are some applications that only work on Android and cannot work on iPhones. So it's like you're now virtualizing Android OS inside your iPhone, just to be able to make use of the Android application inside your iPhone. Okay, so I'm just trying to bring that to understand. So now, why are you virtualizing? Because you just want to do some things, you know, that are not readily available in your present OS. Okay, so when you're talking about virtualization, if you've ever worked on virtualization, virtual machines, when you're talking about virtual machines actually work in such a way like you are sharing your system resources. And when I'm talking about resources, I'm talking about your hard disk, I'm talking about your processor, you know, you're talking about your hard disk, you're talking about your processor, you're talking about your RAM, the hardware resources of the system. That is when you're talking about virtualization, you are making use of these things. So now, and after sharing resources, you cannot spin up a virtual machine without using an operating system. Then you have to install an operating system on that virtual machine. Probably the purest minimum of OS you can use, or the minimum storage that your OS can use is about, let me say about 700 MB. Now, just because you want to virtualize, you posted 700 MB. Now imagine you now have, okay, say you are creating a virtual machine because you want to run a particular application A. Now you now have another application B. You now create another virtual machine. So you now create like 3 virtual machines. Before you know it, you've wasted like 500 gig on just 3 applications. Why? Because you are virtualizing. Now ask yourself, why are you virtualizing? Maybe application A is using Python 3. Application B is using Python 2. Application C is using a dependency, a version dependency, like maybe there's now an update in that dependency. When I'm talking about dependency, I'm actually talking about dependent, like maybe some of the things that your application depends on to work. That's dependencies. So now application C is actually using a particular version of dependency. Like if application D should carry it, it's going to throw an error, or it's not going to compatible. So in such scenario again, you want to virtualize. So now look at it now. You've already virtualized. Just because you want to run 4 different applications, you created 4 different virtual machines. Okay, so know how many resources you wasted. Another thing, you know, when we're talking about web servers, we talked about that you can even start an hosting company. That was when you actually spinned up your name. And I showed you the routing, the directory configuration inside Nginx. You get now imagine you are doing hosting company and you want to be managing different applications with different dependencies. You know, don't forget what I mean by dependencies, because I'll be using this a lot. It's already part and parcel of me. I will say it subconsciously, but then just try and understand what I mean by dependencies. Something that your application depends on to work very well. Okay, all these things, they are just English. So you need a particular dependency. You now start spinning up different virtual machines. At the end of the day, you end up making a loss. So one way you can easily solve that, one way you can easily manage that is using Docker. Okay, it's using Docker. Now, what is Docker? I have trying to understand Docker. Docker is actually an automation tool. You know, it's an automation tool that you can use to virtualize, like it's like you simulating your virtual machine. Okay, or how can I say it? Like it's a virtual machine on its own, but more efficient. And when I'm talking about efficient, it's faster. It's faster. It doesn't consume much resources, you know, and easier. Okay, so it's like a lightweight version. Yeah, I think that's better. It's a lightweight version of virtual machine. And when I'm talking about lightweight, you know, it doesn't really consume much system resources. It doesn't really take much time. It doesn't really take much effort. It can easily be automated. That is what Docker is. Okay. So now when you're talking about Docker, Docker is more or less like an automation tool. It's an automation tool that actually helps developers to easily deploy applications or to easily automate deployment of applications. Okay. Hello. Have I been able to drive that in?
Yes, we are with you.
All right. So that is just Docker. You know, it's an automation tool that actually helps developer to easily deploy application. Now, what I'm saying now, you are going to see it. So it's not just an English. You're going to see the automation that I am talking about here. You know, how it actually helps developer to easily deploy application. So let's get right into it. Some of the okay, before we get right into it, let me just clarify some of the terms we'll be making use of. Now, the first thing you want to talk about when you're talking about Docker, is you want to talk about Docker image. Okay, just take note of those terms. You want to talk about Docker image. Sorry, what's this? You want to talk about Docker image. You want to talk about Docker image. You want to talk about Docker container. You want to talk about Docker containers. You want to talk about Docker Hub. Okay, so let's talk about all these things. So Docker image is how can I define Docker image in this scenario? When you're talking about Docker image is let me say I can just talk about Docker image. Docker image. What is Docker image? Docker image has a set of instructions. Okay, that's it. Docker image is a read-only template that contains a set of instructions for creating containers that can run. Okay, that's not actually what I'm looking for. But Docker image is like, okay, when you're talking about atoms, science students actually know what an atom is. Atom is the smallest, indivisible. But just take note of that word, smallest. The same thing you're talking about Docker. When you're talking about Docker, the smallest object of a Docker is called Docker image. So Docker image is already a constructed is a constructed object that contains all the instructions that you will be needing for an application to run. Those are Docker image. Okay, so I think I actually omitted something. We should also talk about Docker file, but today we are not going to be talking about Docker file. We should talk about Docker file. So Docker file is a file that used to specify instructions that you will be using for building your Docker image. Okay, like just like you'll be running your Linux command, your ls, your touch file, all the Linux command will be running. It's like you are running all those things inside your Docker file. Okay. Now, once you are done presenting the instructions inside your Docker file, then there's a command you are going to use to build that instruction. That is what is going to become your Docker image, and which is what you are seeing here. It said a Docker image is a read-only template that contains a set of instructions for creating a container. So once you build the Docker image from your Docker file, then you create a Docker container. So what is Docker container? Docker container is just like a running instance. Docker container is a running instance of a Docker image. Let me quickly give us an analogy. Now, looking at it now, let's use a car as an analogy. I think I can use car as an analogy. Okay, what actually makes up a car? What makes up a car? A car, you break up different parts to make up a car, right? So, the engine, I don't really know much about cars, but, just bringing up different parts of the cars, bringing them together. So the process of bringing them together, all those different parts, we can see it as your Docker file. Okay, so the moment all those things are coupled together, that is what is called your Docker image. It's just redundant, just there. Okay, then the running instance of that Docker image, maybe during the process of functioning, you are cruising your car in the town, you're just playing around with your car. That is running instance. That's why I call it running instance of a Docker image, which is what is called Docker containers. Okay, so knowing that, let's just go straight into it. Now, to start, the first thing you want to do is to really start your Docker, to really start using your Docker. The first thing you want to do is you have to install this Docker on your machine. Okay. Installing Docker. So you can just go to docs.docker.com. their instructions. It's as simple as running apt-get install Docker, but I just wanted to be sure. Let's just follow. Okay, so this is the instruction. Install.
Good evening, Bolu. You are not sharing your screen.
No, I'm sharing. Is that true?
You can see your screen.
We can see your screen.
Okay,
Your
I
screen
can
now.
see.
I think it's your
I can
internet.
see you, yes. Okay, thank you.
Okay, let me stop sharing and share again.
I've seen it. Thank you.
All right, so now the first thing we want to do is we want to install this Docker on our machine. You can actually install Docker on your Windows. You can use your Windows anyway, but for this class, we're going to be using Ubuntu. So let me start my instance. Okay, so all right, cool. So now let's go to install. It said uninstall the whole. Okay, let me even confirm. It might even become the package itself. Let me see. Docker not found. Okay, Docker not found. All right. So it said you can uninstall this. It's always at times when you want to do things like this, it's always good you go through documentation. Though they are shortcut, just go online out, just give you one command. But if you have the patience anyway, you discover documentation actually helps a lot than just trying to cut corners. Okay, so in the documentation, they said we should try to check if the older version is installed so that we can remove it, apt-get removed. But now I get the instruction like unable to locate package Docker engine. So there's nothing like that running. So then after then, let's go to instruction, update the apt-get. I think we've done this before. Okay, let's run it again to see. I just give you recommendations. Shit. Okay. Then once you update your package, just run this command. Sudo apt-get install. Okay, it's still part of update the apt repository. That's the first thing. Update the apt package index and install packages to allow apps to use repository by CPS. I'm just following those. Please. Let me start another instance why this actually goes in the background. So I'll just leave this to go in the background. Last time, so I think I remember that I actually stopped this process. Let me not stop it. All right, let me just go straight to the real cocoa. So it said Docker official GPG. This is the steps. Which one is this? Okay, yeah, okay. So this is the steps. It said create a directory. So I'm going to create this directory. Just copy and paste. All right. See, take note. See, I'm not copying this $. It's just trying to tell me this command prompt. Remember, I've changed my own to hash now. It's no longer $sign. So that's just what it's telling you. So it's not part of the command. Okay, so use the following command to set up a repository. So the next thing is asking us to set up a repository. So let's do that.
Sorry, Bolu.
Okay.
Sorry. Are we supposed to follow along? While you're doing that, we should also input that at our own end so that we can follow along. Because I don't know, is that supposed to be the case, or we just watch you do
That's what is supposed to happen actually, but how many people? I can't. There's no how I can actually monitor everyone. You know, right?
No. You don't. Maybe you don't need to monitor us just to confirm that we are all following, right? I don't know.
That will
So
slow us
because
down to say.
It's going to
Abi?
slow us down, honestly. So, you
okay,
can
That's
always,
what I've been in the video
video, of course. Just try to flow along, and that's why we have the recorded session. So if you want to go along, you can definitely always check the video. And if you have a question, I always take out time to respond to every questions too. So I think that's better. You still have like 4 days to practice on your own. So let's just do this repository. Existing time. Let's create a repository for Docker. Okay. Now, the next thing now is update the app package index and latest version Docker. It's as simple as this is what I was supposed to even run normally. Install Docker engine. It's as simple as just running this anyway. So now these are other packages that actually need to work. Normally, if I wanted to install, I'll just do Docker install, and my Docker will be up and running. But definitely, I'll still be needing all these Docker Compose, container ID, Docker CLI, and all. Probably there are still some other. Okay, now when you're talking about your Docker Compose, so I don't plan to really cover Docker Compose in this session, but it's also good to know about Docker Compose. But what's Docker Compose? Docker Compose is just a way of managing multiple applications, which is what we are going to be doing with Kubernetes. So that's why I'll not really be talking more on Docker Compose. A lot of companies are not even using Docker Compose like that. I'm not sure, but since I've been working stuff, I've not really seen anybody ask me for Docker Compose. I rarely even see job specification, asking for Docker Compose. But it's always good if you just know about it, just learn about it, and just read about it. So let me just follow this library. All right, so now I'm installing Docker. I'm able to locate, to find package below. Oh, package is not available, but it's part of another package. And package C has the installation candidate. I'm able to locate package. Okay, so I actually think it's because of this update I'm running. It actually needs me. I've not really updated. Okay, video package list. Okay, I think it's done running now. Let me see. All you're still doing now is just trying to install Docker. So it's not supposed to be anything serious. I'm just trying to ensure like my OS is up to date, which can be responsible for this error. It's supposed to be pretty straightforward. It's as simple as just running apt install Docker C. Why is it taking time? All right, so now I think it's up to date. Okay, so let me install these repositories. Not upgraded. Okay, so let me try to upgrade. Say 27 packages not upgraded. Why? CSS is already the newest version. Okay. Okay, let me not waste time. I don't think that should really disturb us. I'm not really sure that should disturb us. Call is already the newest version. Call set manually. This one upgraded. Okay. So I think we already have this. I think I already have this created. Okay. Then we add this repository alongside. Okay. File exists. Okay, do you want to override? Let me just override. Yes. So use the following to set up a repository. So let me set up my repository. Right. Now let me run command now. Okay. Let me try. I think it wants me to update. Okay, so after updating, let's go this install. All right, so it's working now. So if I didn't go to documentation, installing Docker is as easy as just running. It's as easy as just running Docker C, and then you start seeing error. Then, if you take note, the error we saw at first, the error we saw at first. Let's just go there. Normally, this is how you do DevOps. Okay, still running. Let it be done. Then we go back to the error we saw earlier. It actually brought a pop-up, and then I clicked enter, just asking for permission to continue. That's it. Oh, the error is gone. So what I wanted to do was to copy that error we had. Okay, this is like the error message we got, and what I told you about DevOps. What was that? What I did about DevOps, so you see an error, just copy and paste it to give you suggestion. Hold on, let me run this again. I think I mistakenly stopped it. Now, if I don't follow documentation and then I got those error message, then I'll start browsing why. Okay, let me just click on one of Stack Overflow and see what they have to suggest. Majority of the time, they just give you hammer and spanner methods, that I can just build things. Okay, this is still really straightforward. They still told us this is still nice response. And another thing you always look for is don't just do everything Stack Overflow actually tells you. Look out for this check mark, green check mark. Because most of the time, it's good to always read what they are saying on each thread, but the real answer is oftentimes with this green check mark. That is, people can testify like this solution actually works. So once I just see this green, I'm always excited. Like, oh, thank God, it's easy solution. So you can just browse around. Okay, look at this. This is having green check mark. And look at what it just tells you. Just updates. It's just for a moment you can use. So that's what I'm always saying. At times, it's always good to always go through the documentation. Okay. So now we'll be able to install Docker. Once you install Docker, let's just complete the documentation. To install specific version, we'll not be doing that now. So now, after we are done installing, verify that Docker engine is installed and correctly running. Okay, so who can remind me how to start a process? How to start a process? Can anyone remind me how to start a process?
System CTL start the service name.
What do we start? Let's do status. Let's see if it's running.
Status Docker.
Right, so it's running by default. You can see. So if it's not running, you just run systemctl start Docker. So, but in our case, it's already running, okay, by default. So now, it's telling you to use service, but in our case, you're using systemctl. So now, what we've done so far is we've been able to install Docker on our OS. Okay, so now how do you see the version of Docker you have installed? It's as simple as just running Docker -v. It's telling us you are running Docker 20.10.19. So now we are up and running. So any question before we continue? Okay, in the absence of none, remember what I told you. Docker is a tool that actually automates or makes the deployment of an application easier. Okay, and I actually made mention of these things. I talked about Docker file. So Docker file is a file that contains all the set of instructions that you'll be needing for an application to run. Okay, then we have Docker image. Docker image is after running all those instructions, bringing them together, there's an object created. That object created is what we call Docker image. Okay, so now Docker image, the running instance of a Docker image is what we call container. So I remember when we were back in school, when you're writing a project, you have statement of problem, you have statement of problem. So let's quickly do a statement of problem here now. So now, what problem are we trying to solve? What problem are we trying to solve before we started using Docker image? I spoke about these things first, and let me just talk about it again. Most of the time, as a programmer, I've been there before. You are using Windows 10, and now I'm using Windows 10. Do you know we can both be installing the same package, and you will discover like you are having a different error, I'm having a different error. It happens most of the time. NPM user can blame me weakness. I work with NPM, there was a time that I was just trying to install NPM. I used almost a week just to install NPM. Crazy. That was on my Windows then, and then a lot of people that were doing these things together, just in one night, they run NPM. So those are some of the issues you have when you are running on a bare metal, or like when I'm talking about bare metal now, when you're running on like your virtual machine, when you're running on your virtual machine, when you're running on your PC, when you're running on your computer. So those are some of the problems you actually face. And what are the things that may actually cause these things? Probably you've installed some dependencies, or some different version, maybe some package that you've installed. Maybe you are using Python 3, I'm using Python 2. That difference in Python can really be a big difference. A lot of other things will be responsible. But now, what Docker has actually come to solve is everything that application is going to be needed to function. It's going to be created. It's like isolated from the operating system. It doesn't even need to have a knowledge of what is running inside the OS. Okay, it's running independent of what you have running inside the OS, like a container. When you're talking about a container, this is a port now. I have a port here. Like everything that my application is needing, I have it running inside this port. But take for instance, now I'm just trying to maybe I have some grains. I'm trying to pack it with my hand, and I'm taking it to another location. Along the line, maybe I can just bump into someone, one grain will drop. Or probably I just bumped into a wall and I fell down, I lost a couple of grains. But imagine when you have everything inside the package, I can easily move these things from one laptop or from one PC or from one machine to the other, and nothing is going to be lost, independent of the environment. That is what this Docker image is talking about. Now, a lot of developers now, they are learning Docker image because It's a way for packaging application to your clients or for your clients. You don't want to develop an application for a layman and be telling layman, please go, okay, try to install this, go and configure SSH config, go and do this, go and do that. Instead of that, all you just want to tell your clients is install Docker and run this command and do. Everything is up and running. That is what we are going to be doing today. Okay, so let's get into it. The first thing we want to do after installing Docker, is just like your normal programming hello world, is Docker run hello world. Okay, take note of this. Take note of what is okay, I'm going to show you something. Now, we've not really started anyway. I'm just trying to do a quick demo, okay, so that you can see how Docker actually works. The moment you finish installing Docker, just like you're learning your programming language, the first thing you do is run hello world, okay? Now, take note of what happened here. It says, unable to find image hello world latest, okay? Now, remember, I told you image is a set of instructions that you've already built into an object, okay, or call it artifacts, okay. Now it's telling us it couldn't find, unable to find image called hello world latest. You can see that was the first line on display. And look at the next line. It says pulling from library hello world. And then look at the third instruction. It said pull. So now what it's telling you here is what these lines, let me just close this, I'm no longer using it. So what this line is telling you now is, the first thing is Docker is the command, okay? The instruction is run, and the parameter is hello world. So let me just explain this command. This command is Docker, and the instruction is run, and run is expecting an argument, which is the image that you want to run, okay, which is hello world. I will show you how it's getting this hello world too. Now, I'm telling it, okay, please run this image called hello world. The first thing it says is unable to find image. You see, unable to find image, hello world latest locally. And when it means locally, it couldn't find an image called hello world on this instance, on this machine. Once it discovered it was not able to find that, next thing it did was it went to get it from Docker Hub. I was trying to avoid, okay, I talked about it, look at it, Docker Hub. So Docker Hub is a registry where you keep all images, both public and private, where you keep images, not all, you know, where you keep images, both public and private images, okay? So that is called Docker Hub. Let's go to Docker Hub. Let me just show you Docker Hub. Okay, of the docker.com. So in this of the docker.com, you see different images. You see Ubuntu, you see Postgre, you see MySQL, you see busybox. We are going to be making use of this busybox for demo later. You see Python, you know. If you've ever installed Python, you know how Python can be crazy at times when you want to install Python. I battled with Python, you know, some times ago. It was crazy that I had to keep the script for installing Python 3. It's dealt with me because by default, the version of Python that actually comes with majority of the OS is Python 2. I think I use Ubuntu then. Let me see what version comes. Okay, does it? I don't think it has Python installed. Okay, Python did not come with this. Okay, I think it might be a little bit easier. You know, so you have different images, and then you can also search for image here. Okay, and you know we actually use hello world. You can just type hello world here. So this is hello world, and this is the image we are using.
Sorry, I think your screen is frozen. Your screen.
Is that true?
Nothing.
That should be my internet.
There's nothing wrong with the screen. Everything is working perfectly. It's like your own internet.
There's nothing wrong with this now.
I guess it's your internet. Thank you. So now, this is the official image. Okay, and this is how to use the image. This is by the side, you can see this is the instruction on how you can use the image, which is what we have here. When you look at the instruction here, it said it's pulling, unable to find, and then it's pulling. So this is the instruction for pulling, but it's doing that automatically for you. So you are going to be, we are still going to be using this Docker pull later. Okay, but for now, let's just go on. Then I've showed you about this. This is Docker image, okay, which is hello world. So it pulled that. Then this is how it's pulling it, okay. And then the next thing is pull completed. Then some IDs, you know, some shars, some shar ID. Then you have now what now happened? What that command is supposed to do basically is to run this hello from Docker. That's what it's supposed to do. But because the image is not existing, that's why it went through this process. Okay, let me run the command again the second time and see if it's going to run the same process again. You see that the process will be different. All right, you see, it's no longer pulling straight. It went to Docker. Hello from Docker. This email, this message shows that your installation appears to be working correctly. So that is a default. This is an hello world in Docker. Okay, so that is it. So now I told you we have Docker image, we have Docker image, we have containers. Container are running instance of image. Now let's see the image that we have. If you want to see the image that you have running on your machine, okay, or on your PC, it's as simple as just running Docker images. This command is going to show all the image you have. So you see, hello world, latest. Now let me try to run another image. Oh, no, hold on first. Before image, this is image, right? Now, I said a running instance of an image is what is called container. Now, how do you view a container? To view a container is as simple as running Docker PS. Okay, but I think for now, we are not going to have, it's going to have empty. Why? Because the image is no longer running. Okay, now there's now a way, there's a way for you to check a stopped container. You know, I told you a running instance is a container, a running that is already working, but there's now a stopped container that was working that stopped. Okay, the process of running Docker run is you creating a container. That is what Docker run is for. I don't know, am I mixing things up?
No, you are not.
All right, thank you. So the process of running a Docker image, if you want to run a Docker image, that is where you do Docker run, then the image name. Okay, now it's going to run the image automatically. Now, if the image is not appearing, if the image is not already existing, it's going to go and download it. And if the image is existing, it's going to run it automatically. Okay, so now we've actually run an image called hello world, which is already that is already created a container, but now the container is stopped. That's why it's not showing anything. When we are you saying anything? Who's that? Peace of God. Okay, good, muted. So now, to view an already stopped container, it's as simple as just running Docker. Remember, in your LS, you do -LA, right? To view hidden or archive file. But in this case, you can do -A. That's to show all containers. So now, you see, when we run Docker PS, it told us like it's empty. But after adding -a to it, we're able to do something. Let me run it again. Because what makes the difference is just this -a. Without -a, you see, it's showing empty. But with -a, it's giving us value. Now, let me just explain this. These are dead, these are stopped container. Every container you create actually has its ID. So here's the ID. Here's the ID. And what is the image you actually run it from? This is the image. Now, let's try to create another hello world and see. Okay, let's view again. You see, this is the third one, which is run 4 seconds ago. Okay, now look at this, the image. Okay, the image is hello world, and the command is the default command that you actually issue to the container, which is hello. Okay, now this is the time. It's created 4 seconds ago. This one is created 4 minutes ago, and this other one is created 9 minutes ago. Now, what is the status? The status actually means it exited 2 seconds ago. Another one exited 4 minutes ago, and the next one exited 9 minutes ago. Now, when you actually run an image, using a Docker run, it gives it a random name, which is what you have in here now. Just run it another time. See, it just go ahead and just give it a run. Who is using annotation here, Joe? How do we delete annotation now? All right, thank you. So now you just give it a random names. And then anyway, you can also specify a name. Let me try to run. If you want to specify a name, instead of it just giving it a random name, you can just use this what's it called? Characteristics. Give it a name called test. Let's call it test container. Okay, so all right, let me do Docker PS now. You should see the name as okay, yeah, test container. Okay, so if it does specify a name, it's going to generate a random name, but you can also specify a name in the command. Okay, so it might not be making much sense to you right now anyway, but we are going to get deeper into it. The most important thing is make sure you understand what I am doing right now. It's going to make more sense to you as we go deeper. Okay, and I believe so far so good. We understand what I'm doing, right? Or am I too fast?
Not at all.
What do you say?
Not at all. She said not at all.
All right. Is that for everyone? Do we all agree? Please, if you have any question, please you can ask now. I'm actually scared of silence anyway.
For me, it's cool, sir. Even though I'll still have to come and check the video again.
It's what?
I said for me, it's cool. You are going at a very good pace. Even though I'll still have to check the video again.
Definitely, you still have to check the video. Yeah. So, wait though. Wow. What happened? My meeting did not stop after 40 minutes.
Have you forgotten that you paid?
What?
No,
I thought you paid now.
I already stopped I already stopped.
Oh, hand
Did
of
you
God.
message
Hand
me?
of God.
Maybe they've not activated the 40 minutes or what? Since it was not working, I had to go and stop the. Come on.
I think you have a
I guess I'm still enjoying the trial version then. Because since it's already failed me that day, so I already canceled my subscription. Since it was 7 days trial. Okay. Good. So I think so far so good. We are going at a good pace. We are going at a good pace, and I actually want to carry as much as possible along. So now we already have Docker container. Okay, so now we've seen how Docker images run. So to check Docker image that you're running, to check Docker image that you already have on your machine, it's as simple as running Docker images. Okay, and then to check running container, it's as simple as running Docker PS. And if you want to check existed containers, you run Docker PS-A. Okay, so here are all the stored images. How do you know? You see exited. Okay, so right now, let's run another image called busybox, which is what we actually saw here. We are going to be making use of busybox. Yeah, this is an official image. Okay. So also try as much as possible to use official image as well. If you want to use anything, try as much as possible to use official image. And there's still a lot of things to really learn about these things. You can't just learn everything at once. So now we want to make use of busybox. This is just a test image anyway, just for demo sake. So let's work with this and see what's happening. Let's work on this. Let's put the Docker busybox. So it's as simple as just running. Please, can who made this annotation? Can you just delete? Okay, so we have Docker pull busybox. Okay, then let's run it. See, it's pulling from library and then pull complete and downloaded newer version, blah blah blah. So now let's see Docker images. We should see it. So you see Docker busybox. So now after getting the Docker busybox, let's try to run this. Let's try to run it. So to run Docker busybox, can someone just help me with a command to run Docker busybox? Can someone help me with a command to run this? I want to run this busybox.
Docker run busybox.
Docker run busybox.
Thank you. So now
Docker run busybox.
Yeah, I ran it, nothing happened. Okay, nothing happened. Now let's go and check what we have. So at times, it's just, you can also troubleshoot what is happening, do Docker PS and see what is happening. You see, empty, that's actually to tell you nothing is happening. Okay, that's to tell you nothing is happening. So let's now see what is happening. Do Docker PS-A. You can see the busybox, look at it. It said it quitted 31 seconds ago. Can I run Docker logs? I think I can also run Docker logs. It's been a while I actually use Docker anyway, but it's just good to just know these things. I think you can run Docker logs to see what actually happened. Docker logs. All right, I think it's kind of empty. That's why it shows empty. Yeah, I think if it's actually okay, let me run on another container and see. Maybe you can read logs. You know what logs is? To just see what has happened so far inside that container. All right, yeah. Docker logs is valid. So now it's just a troubleshooting means. There are sometimes you run container and you don't get the kind of response that you're expecting. Just run Docker logs on that particular image. You can see what has happened before. Remember I told you Docker PS tells you nothing is running. That is, it's not working, right? To see what is happening, just do Docker PS-A. And then these are all the containers that have that ran in the past or are stopped. So, and then this stopped, and you don't have explanation, you don't know why. Maybe it's not supposed to stop. But then you discover the stop. You now want to figure out what is happening. Just run Docker logs. Run Docker logs. Then the container ID. You can either use the container ID or the container name. Any of them will work. Docker logs. So this is because the log is actually empty. Okay, because the container is not supposed to do anything on a normal day. So after that, let's do something on the Docker on the busybox. On the busybox, I don't know if you actually worked on Echo when we are doing Linux commands. Do you know what this command will do? This command is just to print this string here. So now we want to get busybox to print a particular string called "my name is Bolu." Okay. Now, like this is your normal Linux command, right? Hello.
Yes,
Yes, sir.
We worked on
100.
command when we are doing Linux. It's just for you to print a string on your command on your terminal. STD out. Okay. So now let's get Docker. Let's get this busybox to print this same thing. So now let's do it. Let's pass a command into it. You can pass a command into a container. So it's as simple as doing Docker run busybox. Okay, no, let's do it. Let's give the container a name. To give the container a name, we do double hyphen name. Test busy. Or let me just call it busybox. Busybox. Okay, then what is the image? The image name will always be the last. Okay, when you want to run, that will always be the last. Okay. So now the image name is busybox. Okay, so after that, we now want to issue a command into that running container. So how do you do that? You do that by just specifying the container after this image name. You know, I told you Docker run is expecting an argument. So after the argument, then you can now put the command that you actually want it to run. You know, let's say you want it to run your echo my name is. The normal thing you can just do on your Linux system or on your Linux terminal. You know, you can always do it there. So, you know, before it was showing something empty. Now you see it's showing my name is Bolu. Now let's run Docker ps-a and run our Docker logs and see what we have. Let's run our Docker logs and see what we have. All right, so you can see from Docker log, remember before we were getting nothing. So with the Docker log, you can always use to troubleshoot what is happening. Maybe later on you see more of that too anyway, but just take note, it's going to be a very useful tool as we go on. Okay. Let me also show you another demo. You can also do ls. Okay, it says there's already a container. Look at it. Error response for demo conflict. The container name busybox is already in use because I didn't delete. So busybox, let me call it busybox 2. Oops, wrong. This is supposed to be the image. That's not the name. This is the name. I'm going to name it busybox 2. All right, so you can see it actually listed ls, what your ls will do normally. That's what you are doing here. Okay. So are we good? Hello, are we good?
100, sir. 100% for me.
Yes, we are.
All right, happy to hear that. So now, the next thing we want to do now is we've already messed up the old system. We've already had a lot of exited image. How can we delete all these images, containers? Now, remember, running instance of an image is called container. Now, there's no way you can delete image when you've not deleted container because the container is actually relying on the image to run. So let me say, if I want to delete, this is the command for deleting image, docker rmi, which is remove image anyway. So now let me say I want to remove the image called busybox. It's going to tell me I cannot remove it. Why? Because response, unable to remove repository reference busybox must false. Container is using its reference in image. So it said container, this is using it. Here's the container. So you can see the container ID. It says it's using the image called busybox. So now, how do you remove a container? To remove a container is as simple as docker rm, docker rm, then the container ID. You can use the container ID. Okay, so now let me run the docker PSA. You see, it will have deleted that. So I've deleted this. You can see. And then you can also delete by using name. You can also delete by using name, docker rm. Let me delete this, that's name. So, okay, I think it's deleted. Okay, yeah, it's deleted. You can't find it. So you can delete by any of those two, either by names or container ID. Okay, so you can also delete multiple images at once. You can just do docker rm, then specify the ID, and let me see another one. I want to delete this gifted, right? I want to delete this as well. So you see, it actually listed them as deleted. Let's run docker ps now. So you see, we only have 4 left. Okay, so that's how to actually delete image. Then another way to also delete image, is by using status. You can also use filter for deleting image. Okay, so if you remember, if you want to list your image, how do you list it? This, right? You use this command docker ps-a. So you can also give it another option of -q. -q is just to list the IDs. So you can see the IDs, right? You can see that is what is actually displaying here. That's -q. Now you can now also do something. You can also filter. Let's assume you want to filter or you want to delete only the exited image. Probably you have a lot of image. You only want to delete the exited image. It's as simple as just adding another option called F. Then you specify the status as exited. Okay, so let's say you specify status as running, it's going to show nothing. All right, so that's just a way for filtering. So now, that's in all these IDs now. All these IDs, you can now pass it. You can now pass it to docker rm, and it's going to delete everything for you. Okay, so you can just simply run docker. Docker rm. Then how do you pass it? Like, instead of you just deleting it one by one, you can just run a simple command that will delete everything for you, which is as simple as just running like this. So now what this is saying is, I'm telling my command line to get all this command. I'm going to paste it. Oh, okay. Now this is what I'm doing here now. Docker rm. I told you docker rm is for removing containers with their container ID. So now I'm now telling, okay, guy, get all the containers. Get all the containers and pass it to Docker RM. Okay, so that's what this is going to do. You can see this symbol here. So that's a way of passing variable to a command. Okay, so now run it. Unexpected syntax. Oh, what am I missing here? Oh, I think I pasted it twice. All right, so now let's see Docker ps-a empty clean. Okay, another command. Okay, let me quickly create a few images and show you another command that you can use. There's another simple command that you can also use in doing that. Okay, let's just do this. Docker run. Just do a little word. Okay, so now we should have like 3 exited images, exited containers. Okay, so you see the random name. So another easy thing you can do is running Docker prune. I trust much as well to avoid Docker prune anyway, because it just removes everything. Docker prune, Docker container prune rather. Docker container prune. So now we said this will remove all stop container. Are you sure you want to continue? Yes. All right, so let me run Docker PS now. It should be already cleared. So I think I can also run Docker prune. With Docker prune, that should also remove even images, angling images. Oh, is it Docker image prune? We have to add image. Okay, yeah, this will remove all dangling images. Okay, yes. All right, so let's run Docker images and see. Oh, yeah, it's still running. This, are you sure you want to continue? This will remove all dangling images. Well, I actually have no idea why it's not removing. But if you don't want to go through that route, how can you remove image? Wait, or is it like I'm missing something? Let me run it again. Is it image or images? Oh, no. You know, okay, instead of going through that route, I think what is really happening here is during the process of building images, this is how Docker works. Docker actually works by building layers upon layer. It's just like Docker actually works as if you are building a house. Okay, you lay the foundation. I think I'm going to explain that. It actually works based on layers. You lay the foundation. So maybe after laying the foundation, you actually want to use brick walls. You know, you do your brick walls. Then at another stage, you want to use what's it called? All these railings. You put your railings. Then at another level, you want to use these security wires, all these barbed wires. You know, like you're just creating different layers. Now that is what is happening. So each layer is going to be saving the object, the image. Is going to be saving it. You actually see that in demonstration. So at the end, if you now run Docker images, you see a lot of dangling images that are just littered all over the place. That is what this Docker prune is actually going to do. Now, these are the real images. Now you can just remove this by running Docker RMI busybox. Okay, there was a mistake. I think I was running Docker twice. All right, so let's run Docker images now. Okay, so you see we've removed busybox. So that is just the brief concept behind just managing your images and container. So before we actually do the real thing, do you have any questions? Before I quickly before I quickly give you a quick demo how you can use Docker image to deploy an application before we call it a day. Any question before we move on?
No question.
All right. So now, if somebody has an application, if you have an application, there's a way you can just containerize it. Let's say somebody already has an application, containerize it. So we are just using the person's image. So I have somebody's image that I plan to actually make use of here. Let me just browse it and see if I can see it. This is Raka. Okay, yeah, Raka static site. So I plan to actually use this image because this is an image I actually came across when I was just trying to prepare for this class. So let's make use of this. So this person already has an image. This is the image, which is in GitHub. Let's see what it actually made up. So this is an application. So we have Flask, you have static sites, you have a lot of codes inside. But I think let's see if we have instructions of how to make use of it. There's no instruction. Okay. All right, but that shouldn't be a problem, I think. That shouldn't be a problem. Now, let's run this image and see what we have. Before now, let me see if I still have my Nginx running. I joined late. I will have to rewatch the video and send my questions across. Yeah, bro, anytime. All right. So let me try to get my machine IP coil ifconfig.me. Okay, machine IP. Let me see what I still have running. I still have my Nginx running. All right, so I still have my Nginx running here. Now, let me just do something. How can I demo this? How can I demo this? How can I demo this in the best possible way? Trying to think of the best way to demo this. So, okay. Now, first thing first, let me stop my Nginx so that it will not conflict. Or let's do this first. Let's do this first. Let's just follow what this guy is having. This is the instruction he has. Remember your Docker run. Remember your Docker run. And then this -p is just a way for mapping ports. Okay, it's just a way for mapping ports. Now, the application is actually running on this port 888. I mean, how can I explain that part? Inside the Docker file, okay, take for instance now, our Nginx by default was running on port 80, if you remember. By default, it's on port 80. But this application that this guy developed is running on port 888. Okay, so what this option is trying to do is trying to map port 888 to port 80 on our PC. Okay, so now that's what this is that's what this command is just it's all about. So we have Docker run -p. This -p is just to specify the port. It's for port mapping. So here we are mapping port 888 to port 80. And I told you the image name will always come last, which is the image we are working with, Raka 9089. Okay, so let's run this and see. But since we already have our Nginx running on port 80, So I want us to change this to maybe port 81. Okay, so we can just check it on port 81. Unable to find the image. So you see it's pulling. Okay. I'll definitely take time to explain all this. I just wanted to finish pulling.
Yeah, but can I ask a question? Or
Okay.
when we're done?
Please go ahead.
Yeah. Is it possible to connect Docker desktop with this Ubuntu virtual stuff that you're doing? Is it possible?
Yeah, you can.
That running it.
You can download Docker, of course.
Yeah, I know, right? What I'm trying to say is that you are trying to do this project that's walking us through via the virtual machine, isn't it? So I'm trying to say is that rather than installing the Docker that you did on the virtual machine, is it possible to really connect it via the Docker desktop while you just do all the necessary stuff that you're doing?
Of course. You can just install your Docker desktop and you run the same command as you're running on Docker. As all this that will be running, you can also run it on your Windows. I'm not sure. Maybe I've even installed Docker before. Let me see. The site tendency I have it.
All I'm saying is, this putty, like you are running putty commands, like you are running Docker commands in putty, isn't it? What I'm saying is it possible for you to really connect that of desktop? Once you install Docker desktop, it's also going to see it as what you are running on your machine, like on your computer. So that of putty, it's more of like a separate environment.
Yes.
Yeah. So is it really possible for you to connect once you start your Docker desktop? Then is it still going to be doing what you expect to do?
It's a different environment entirely.
Exactly. That's what I'm asking.
A different environment.
Because that is kind of resource intensive, but no problem.
Why is it taking infinity, man? Oh, shit. My bad.
I'm kind of confused why the NGNX is still running.
Now, this is what really happened. It's already working. That's what we have here now. This that we are seeing, it means it's running. Okay. So, let me see best way to explain. Now, this image is actually running as a process. You get it has a continuous process. Let me start a new session. Let me duplicate session. And so we can run our Docker PS. So let's run our Docker PS now. So you should see running image. Come on. Come on, bully. So look at this now. You see, remember in the past, when we run Docker PS, you are seeing empty. But now we are seeing created status is still up. You can see no longer exited. Now, if I go to my same IP now and run it, if I go to same IP, remember I'm actually running, remember I actually mapped it to port 81. So I have to specify ports. You specify port. Now, if you not specify ports, it automatically defaults to port 80. You see, it deletes it because by default, every website is running on port 80 by default. Every URL is running on port 80. So if you want to change the port from 80, that's where you specify the ports. Like this, you just do semicolon, then the ports, and hit enter. All right, so now it's telling me nothing. It can't see anything. Let me see what is happening. Let me try to figure out what is happening here. I can't see anything. So in our case now, let's try to troubleshoot. Let's run coil and see what we have. Failed to connect on port 81. Okay. Let me see if I have my security group. So I have to check my security group if I enable port 81 on the same instance, you know. Now this is troubleshooting step. These are definitely, that's DevOps. There will always be problem. You must be good in your dev. You're not doing the same thing. Like everything you'll be doing will still be around Docker, Kubernetes, you know, Linux environment, but you keep having problems. I have to keep on troubleshooting again and again. So that's why we are treating this Docker and Kubernetes. So this is what we are expecting, but we are not getting it. Now it's telling us we have ports. All ports are, it's supposed to allow all ports, okay? So this is definitely strange, why it's not working. I have no idea why it's not working, because all inbound is allowing all ports, all protocols, all source. This 0.0 actually means from all. So why is it not running? Okay, let me go to my instance and do coil localhost port 81. Fail to connect. Would it be the issue with the image, with the container itself? It's not even saying anything. Okay, so let me troubleshoot what is happening here. Let me run Docker logs. Nginx is running. Okay, so what's happening here? Oh, is it like I was missing something? Okay, let me do something. I'm going to go the reverse way. Let me run this image again. I'm going to run the image. I think I actually mixed it up. I think I mixed it up. I just want to be sure. Restart. So when I mean by I mixed it up, since it's running on Nginx, sorry. So I think it's our system port that is 888. Okay, the app ports inside the container, inside the image is 80. So the port that we want to see it from, I think this is what I think that's the one that comes first. I just want to be sure. Let me try it. Before I was thinking this is the port where the application is running, and then I'm mapping it to my port 80. But in this scenario, I think the issue is this is the port the Docker image is running, the Docker container is running, then I'm mapping it to any port of my choice. So therefore, I'm going to change this port. So let me just change this port to 880. You can see. Okay, so we have Nginx is running. Okay, so let's go back and see. It's running on port what? 880. Let me try to call it on port 880. Yeah, so you see, it's running now. Now you can come here and do port 880. Hello, Docker. So that's the simplest way of deploying applications. So it's as simple as that. Now, if you want to deploy anybody's application, it doesn't matter. It doesn't matter how big the application is. It's as simple as just doing this. Somebody can write a whole Google and just containerize it, and it's going to give you the Docker image. And the simple thing you just have to do is just run Docker run, do the port mapping, boom, it's up and running. You're not doing any configuration. That's the beauty of container image. You don't have to start doing apt installed. You don't have to start doing manual configuration. That is the beauty of using containers, of using Docker. Okay, so now that I've been able to establish that, take note of this now. The way this is actually running is it's running as a daemon process. Unlike the one we ran before, like it's going to run and stop. This is actually running continuously because Nginx does not stop. This Nginx is being run as a daemon process. Okay, now let me stop this. If I stop the container, stopping the container, I think it's as simple as just pressing Ctrl+C. Let me run it again so that I can take note of what I'm doing. Let me run it again. So if I run this, okay, before running it again, if I go back to the site, it's down already. It will be down. All right, so it's down. Now just run it again. You notice it's not going to return me to this command prompt. It's just going to show running. Okay, this is what it's going to show. Keep showing running. Okay. Now it's automatically reloaded. It's automatically reload. That's why we see this traffic. See, this is the traffic that we are getting. You can easily see this traffic. If I actually see the response, if I actually reload again, let me try to reload. You see, it's going to take effect. Let me reload this browser. You're going to see the traffic flow here. So every time I reload, you're going to be seeing it. You're going to be seeing the effects. You can also use that to monitor traffic or do your troubleshooting process. Okay. Now let's assume you don't want to do this. You don't want to be doing it interactively. You can just there's this option you can also pass. Just stop and run it again. Like, okay, before I do that, let me show you something. Just the time. Okay. Now I've stopped it. Let's run. Okay, no, let me run it again. I'm going to run it again so you can see something. I want to show you something. Now, let's go back to the second terminal and run That's not show Nginx yet. It is showing Nginx running. Okay, now Nginx is running. Let's come back to this terminal and run docker ps. So let's run docker ps. Docker ps. Okay, let me quickly do some explanation here. So now, this is actually telling us we have two containers running. Look at the first one. Let me increase the width and run it again, so it can be on a single line. Okay, so now look at the image, which is the image we run. Then this is the entry command. I will explain this in our next class. You have a good understanding of what this is. So now this is about a minute. The status up 54 seconds. Now this is the port. We have TCP 443. We have these are the ports that it's running on. We can't use 443. I think 443 is actually that's for SSL, you know. Besides, we didn't even do the mapping yet. So now we have port 443 TCP. Then we also have, look at this 0.0.0. This is actually telling you from all source, okay, can access it on port 880. So if traffic is coming from any source through this port 8880, map it to this 80, port 80 on our Docker. That is what this is telling you, and still the same thing that we still have here. Okay, so now coming here now, you see it's still running as this is still running as a daemon process. Now we can stop this, but let's say, you know, the moment you run a container, there's something we actually call running a container in a detached mode. Okay, you can run a container in a detached mode, which is as simple as you just running docker run. You just add this okay, before we do that, let me quickly show you something. Now, you know, in our case now, we did the mapping ourselves. We mapped it to port 8080 ourselves. There's another command that you can actually use in doing automatic mapping. This is small lowercase p. You can just use uppercase p. If you use uppercase p, it's going to do the auto mapping. It's going to map all the necessary ports. Let's do it. Let's do it now. It's going to do the mapping, the port mapping automatically. Okay, you can see it's running. So let's go back. Let's come back here. So now we have, let's do docker ps. So what is the new image name? Okay, 26 seconds ago. So you can see. Now, what is really happening here? You can see it has automatically mapped all the ports. Initially, because we did manual port mapping, we didn't map anything, but look at this now. It automatically mapped port 80 to 4915154. Look at it. This is how you know the port that an image is running on. Let's assume you don't want to do manual mapping. It's going to map it automatically for you. So now the application is running on 49154. Then port 443, if you want to access port 443, which is the HTTPS, you can access it on port 49153. Now let's test this now. If I copy these ports and then go to my browser, it should be dead by now. If I reload this, I think it should be dead. It's already dead. So now I'm going to update the ports. Right, so you can see it's up and running. Okay, so I believe it's getting more interesting now, right? All right, good to hear. I didn't know somebody actually dropped this. I'm happy to hear you are finding this interesting. DevOps is really interesting. So then that is how to do automatic port mapping. Okay, so now I'm going to stop this. Let me stop this. So I want a scenario where I don't want to be, let's assume I only have one terminal. So I don't want to have reasons to be stopping instant, because once I run it, I won't be able to do anything on this terminal anymore. Because it keeps running. The moment I stop it, I'll not be able to do anything. The moment I stop it, it's going to fail here. Okay, so in such scenario, there's something we actually call running container in a detached mode. So it's as simple as just running this. It's as simple as just adding -d to run it in a detached mode. Let me use the manual mapping, okay, so that it won't be changing. And then you put -d. Okay, so you put in -d actually means run and exit. Run, keep running, but return me back to the terminal. All right, so you can see it's returned me back to the terminal. Unlike before, it's going to keep running. Now, let me do on that same terminal. I can now run my Docker PS and see what is happening. So you see, 12 seconds ago, then I can access my port 8880 again. I think this should be down because I already stopped it. All right, so let me do my port 8880 again. Good, we are back up. So that's running a container in a detached mode. It's as simple as just running -d. Okay, so now the question now is, how do you stop a container? If I want to stop this container now, let's assume I want to delete this container. If I try to delete this container, remember how to delete a container. To delete a container is docker rm, then the container ID. It's going to tell me it's running. Stop the container before attempting removal. So how do you stop? It's as simple as just running docker stop, then the container ID. So if I run my Docker PS now, you see, you only have one running container running. So let's do Docker PS. All right, so I've been able to stop it. Then that same container again, I can just go ahead and just say Docker rm, then container ID. What's the container ID? Okay, this is the container ID. Docker rm. All right, so I've been able to delete the container right now. So before we continue, do you have any question?
Okay, so thank you, bro. Good evening, everyone. So I've been
Your voice is breaking. Your voice is
in my hand for a while, and I guess you mystified what I wanted to ask. I would like you to talk about. Is it still breaking? Can you hear me now?
Yes, yes, yes.
Oh, very bad network here. Oh, can you hear me now?
Yes, yes.
Still breaking?
Oh,
okay. So thank you. My worry has always been in inside of Docker. It has been about these port mapping. Yeah, thank you. About port mapping. Verify that to be sure, want to verify. The fourth one, if I say that /p 8880 column 80, it means that column 8, sorry, it means that port 80 is what is exposed from the container.
Yes.
Port 8880 is what you can access it from when you are connecting from outside. Is that correct? I just want to be clear about that.
Exactly, you're right. So
okay. So if we go to, is it the Docker file that always contains that information that talks about the port that was exposed from inside the container? I know it's one of those.
Exactly.
I'm not too sure.
Exactly. We are going to be dealing.
Okay.
We are going to be dealing. Talking more more in depth on this. Let me show you. This is the container we are working on, and then the guy actually has this on GitHub. Let's go to the GitHub and see. Let's see his Docker file. So we are going to be working more on Docker file in our next class. Remember, I showed you something earlier. When we were, okay, look at this, wrapper.sh. Is the same file that you see here, wrapper.sh. This is a script that is running. Once you open this now, let's see what is inside this script. This is exactly what you are seeing. When you run the image, if you remember, when we run the image, all we are seeing is Nginx is running. If you remember, I can't find it now. Okay, look at it.
Yes,
Nginx is running, which is what you have here, which is the script. Then this is just a command for running Nginx. Okay, so now let's go back again. This is now the Docker file based on your question. Based on your question. Okay, yeah, by default, Nginx is running on port 80. But there are some scenarios where you might need, like, let's say for instance now, you're running a Django, that is Python. It's a Python framework. I think it actually runs on port 8080. In such scenario, you have to expose port 8080. There's a command that you use for exposing. We are going to be talking more on this in the next class. So let's assume a web server is running on a different port now. You can just easily expose those ports, by using the expose command. So in this scenario, what we are having now, the reason why we are using port 80 is because it's port 80 that is exposed by default from this container, from the running container that we have in. So now we have to specify. Let's assume we don't even know the port that it's running from. That is why we actually use this automatic port mapping that maps all the ports automatically.
Yeah, thank you. That's fair. The second question I would like to ask is, you are running these from the server you had before.
From what?
On AWS. From the server that you had before on AWS.
Okay.
Where you have installed Nginx, right?
Okay.
Now, if I am doing this, so suppose I have a computer, suppose I have a Linux computer, okay, and I want to pull this image and run it. Do I need to install Nginx on my system, or the application will do it? I mean, I just want to know, is it running on Nginx because you had already installed Nginx? No. You have done your yum install, no. Whatever. Okay.
Let me show you the Docker file. Now, there's something we actually called base image. How do you specify base? I told you when you're working with Docker actually works as if you are building a house. Every foundation, you must create a foundation first. So now, every Docker actually has a base image. How do you specify a base image? You use this command from Nginx, which is what it's using. Now, let's assume your base images, you might want to use Ubuntu. Probably you need some packages from Ubuntu, just from Ubuntu. So now, the reason why we are seeing Nginx is because Nginx has been installed inside this image. Let's assume it's not even installed. I can even do it I can do it in such a way like, guy, use base image of Ubuntu, install Nginx and deploy Nginx for me. We are going to be working, this is what we are going to be dealing with in our next class. Okay, so now Docker image is running independently of whatever thing you have inside your machine. It doesn't even care if I have Nginx before. The only problem that will happen, if you remember, when I wanted to start, before starting, I had to do systemctl stop Nginx. Why did I do that? I did that because that Nginx is running on port 80. Now, if I'm running another application on port 80, there's going to be conflict. Let me show you. Let me show you that. Oh, I tried to stop this, but I was not able. Okay, now let me show you now. I have Nginx running before now, systemctl status Nginx. All right, so we have it running. Oh, all right, I didn't really stop it. Now, let me try to run this image and make it run on port 80. Let's see what's going to happen. Definitely, we are going to see error message because all of them, they are running independently. The only thing is, we are mapping. Let me map it to port 80 on, this Nginx is already running on our machine on port 80. Okay, now let me run this on port 80 again and see what will happen. It's going to complain. Like something is already running on port 80. Error. It said bind or address already in use. Now let me stop the Nginx and run it again. All right, so you see, everything is working fine. So now that is what containerization has actually helped you to, it's helping us to do. You can easily create, it's a way of isolating different things. You keep isolating, you see, now I can have multiple instances of Nginx running inside a single container. I can install another Nginx inside another container, map it to port 82, install another Nginx, map it to port 83, with little or minimal resources consumed. I don't know how all this web hosting company actually does it. I don't know how they do, but one thing I know is I can start my own web hosting company with something like this. I'll just say, bring your application, I'll deploy it for you, I'll manage it for you. I don't really have much to do. I just have to have a good knowledge of all these things and at least be able to do backup so that in case anything happens, I can easily restore. The only thing I just have to do is have a good backup system and then do all this and set up application, and maybe I'll just spin up a server on EC2 or on AWS. I don't know how much I'm going to be paying because I don't really use the service anyway. I work for a company that actually pays. And let's assume I want to use free tier like you are using. I'll use free tier for 1 year, get people to pay. I'll deploy the application as much as I can, and they will pay me. Just that's how to start web hosting companies. I can easily start my web hosting company by just running these Docker images, soft.
All right,
Yeah,
thank you very much.
question.
I enjoyed that response. Thank you. Yeah, sure, perfectly.
All right, thank
Thanks.
you. Do you have any other question, please? All right. In the absence of no question, let's just call it a day.
Hello, please. I have a question, please.
All right.
First of all, thank you for the good work you have been doing so far. Here is my question. Is it possible to run the parameter P and D at the same time, like doing the port mapping and the detach at the same time?
They are doing different things, of course. The D is for detaching, like, okay, you don't want it to continue running because you want to do other things on the terminal. Okay, and the IPB is just for port mapping. Another thing I didn't even mention, let me quickly show you this again. There's even another one that you can even run. They call it interactive mode. There's another one they call interactive mode. Let me see, is it possible to run -D and yeah, I should be able to run -D and -T on the same. It's just this question now. So interactive mode. Oh. So now this is the port mapping. Okay. Then -D is detached mode. Then to run interactive. That interactive is actually telling us, okay, spin up this container, log me into the container, and I still want to do other things inside the container. Okay. Let's do that. Let's see. Interactive. Probably that will help us to explain better. Okay, it's not allowing us to use -D with it. Let me remove -D. Let me remove -D. Okay, it says it's already allocated. So I have to stop.
Yeah, I guess the previous container is still running on port 80.
Yes.
So we're starting on that one.
Okay, I think IT, that is interactive. So let me show you. Yeah, I think I also have to specify the bash to the set the bash. The terminal actually what to use. Let's use SH. You have to specify that. All right. So now, because I actually want to run it in interactive mode, I didn't really want to talk about this today, but since you just asked that question, I just like to talk about it. Now, this SH is just the terminal that I actually want to use, which is SH. This is SH. We have different terminals, so it depends on the terminal that you have on the image. Okay. But majority of container image has SH. So if SH do not work, we try use bash. At times it's bash, at times it's SH. Okay, so now you just specify what this is actually doing is log me into the container. So now what I just did is I logged into that running container. Okay, so now let me show you. Let me run ls. So this is ls. Okay, ls of the container. Now look at this here now, wrapper.sh. When you come to the Docker file, this same wrapper.sh, that's what we have inside that container. Now, look at this. This is what happened. It says copy that wrapper.sh into the container, which is what we are going to be doing in next class. We've seen all this in depth in our next class. So now we have this wrapper.sh. This is the wrapper.sh. So I can do a lot of other things inside the container, manual configuration. Let's assume I even want to walk around the engine itself. I can do VAR. It does not allow to predict, so I don't want to work on Nginx. So there are just a lot of things you could just do inside the same container. I'm going to be working more on this next class.
Thank you very much.
All right, you're welcome. Any other question? All right, yeah. Thank you for taking time out. I believe it's all worth our time. So should we have our next class on Thursday or Sunday? Let's have our next class on Thursday.
Yeah. It's okay, I guess. It's okay by me, sir.
All right,
It's
all right.
comfortable for you.
So ahead of the class, you can just try to study more on Docker. I'll try to upload the video tonight, so you can look at the channel. Since I'll just copy and paste it on the channel straight, so nothing serious. So just look out for it on the channel, because I may just upload and sleep, because I cannot be watching it already.
All right, sir.
All right.
You guys should be around 12:07 a.m. over there.
Yeah, 12:07. Yeah. So somebody actually asked what's the difference between system CTL and service. It actually depends on operating system anyway. From my understanding, system CTL service. First. It depends on the operating system. System service manager to manage the services. Contrary to service command, manage the services by interacting with the system, the process, instead of running the init script. Okay, system service. System is the main utility to control the one services system. But let me see. On our hand, can we use service here? There are some OS that does not really use service anyway. Oh, all right, yeah. So we can actually use service and service. Let me see, service stop nginx or recognize service status SSH or recognize service. I actually don't know much about this, but that's the command. Recognize service. I think service. Let me just what's different between service and system CTL. What I just know is they are both used for managing processes, but I can't really pinpoint the difference. And based on from my experience, it actually varies from OS to OS. System CTL commands which is mostly used to enable service to start at the time. System enable service, what is the use of service starts. Both commands are used to up and down services in GNU, but service command is using by sys init and system by system D. Okay, in system D, service command exists, but only to legacy compatible with old. Okay, so this is it, only to legacy compatible with old system. Because actually, from my experience there, I remember I was having this issue there. I think CentOS 7 actually make use of service, and then when I moved to CentOS 8, I think I was getting system CTL. So it actually depends. It depends on the OS. It depends. This is here we are talking about legacy compatibility. So it actually varies, but they are still both doing the same process, which is what we have here. They are both used for managing process. Okay. So I actually think based on what you have here, you said service command is using by system V, and okay, system D service commands exist. In system D, service command exists yet, but only to legacy compatible. Only to legacy compatible. So I don't really bother myself about it, though, since I don't really make use of it. I just make use of my system. I just look around. Okay, what is working on this operating system? Is this service? It varies from operating system. Okay, so just try to confirm. Is it using service or using system CTL? So anyone that is working with just use it for managing your process. Okay. All right. Thank you. Any other one? All right. Thank you very much. Have a good night. Bye-bye.
All right, good night. Thank you.